Hello and welcome to day 11. Day 11 for me, not for you, because it is the 16th and I am catching up. Let's go. Okay, so we are on day 11, seating system. We're on alliterations of S's now. Your plane lands with plenty of time to spare. By modeling the process people use to choose or abandon their seats in the waiting area, you're pretty sure you can predict the best place to sit. You make a quick map of the seat layout. The seat layout fits neatly on a grid, so it will look something like that. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. Okay, so there are two rules, really. The third rule means nothing changes. If a seat is empty, which is represented by an L, and there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied with a hashtag or a pound sign, and 4 or more seats adjacent to it are also occupied, the seats become empty. The seat becomes empty. Okay, 4 or more seats adjacent to it. Okay. So after one round, of course, everything gets filled because everything was in fact empty. After a second round, the seats with 4 or more occupied adjacent seats become empty again, and so you get this. This process continues for 3 more rounds, and then we have the chaos stabilizes, and further applications of these rules cause no seats to change at all. So we want to go through and find out the number of occupied seats. How many seats end up occupied at the very end once no seats are changing state? So if the after state equals the before state, we can say, okay, the loop is done. We're done looping at this point, and now we know that we're at the final stage, and we need to assess how many seats are occupied at that point. Okay. Interesting problem. We might end up breaking this day into 2 different videos just because I'm guessing that this one will be a little long for both sets because we need to do adjacency, which might take a little bit of time. And we need to process the seats, and then we'll need to throw that process into a while loop. So we might just end up with quite a bit of code here today. So we might end up breaking this into 2 videos. Okay, day 11, the seating system. Let's go. So what is our input? Let's just start off with the sample input here, and we will. Where did this go? There it is. Okay. There it is. Okay. So our sample input. Let's close day 10. We're gonna use this as our sample input. We've got our data that we are opening, perfect, and then we've got this, okay? So we're going to have this. We're going to have some kind of function that I'm just gonna call process seats. Process part 1 seats. We're going to have the grid, which is the set of seats in there, so I'm just going to call it grid, and then we're probably also going to have another function that is going to have to do with the adjacents. So we're probably, I don't want to say just, let's say part 1 adjacents. Okay, and we've got once again a grid, but we also have a row and a column, right? We're going to use a row and a column to find all of the seats around it, and then figure out whether they're occupied or not. Okay. Okay, there we go. So part 1, first off, we're going to assume that we process part 1 seats correctly, and we're just going to start off with, okay, here's the process, and here's what part 1 should look like, right? I said that we would start off with a while loop. So we're going to have a while loop, and we're going to have an after value, which is going to be the process part 1 seats, right? And we're going to pass in the data. Let's continue to use the words grid here. Actually, we'll just change everything to grid. It doesn't really matter, but I'm thinking of it in terms of a grid. And if after equals grid, then we can return the, we want to count the number of occupied seats, right? So we want to return, we want to join all of the grid together, and we want to count the number of pound signs in there. Oh, need a period. String dot join. Okay, and then we can say if we don't return that though, then we're going to say grid equals after. Okay, so our new grid is going to be our after grid. No. Yes, grid is going to be after. So after we process this, it's going to be our new grid. Okay, and I'm assuming that that we're going to reopen the data probably, or create a copy of the data. We'll just reread it into memory because we're processing the grid and we're actually changing the grid in memory at this point. Okay. Process part 1 seats. So this is where we're going to go through and we're going to have to determine, okay, what are the adjacents, okay, and if there are 4 occupied seats around that individual, then we're going to mark it to become empty, and things like that. So we're gonna follow those particular rules. Okay, so at this point, we're going to have a new grid, which is going to be an array, and we're going to say for row in range length grid. So we're going to iterate through all the rows, and we're going to have a new row which is going to be a string at this point. So we're going to create every new row as we go along, and we'll add to it either an empty, or we're going to add to it a pound sign, or we'll add to it whatever the current value is in there, and things like that based on the rules at this point. So at this point, we're going to say for column, too many spaces, in range length grid 0, the first row, right? Because it's going to have the same number of rows as, it's going to have a different number of rows as it will columns. So we need to grab the first row and find the number of columns. And we'll say that the adjacents are going to be our part 1 adjacents. There we go. And we're going to provide the grid, we're going to provide the row, and we're going to provide the column per this up here, right? So we're going to provide the grid, the row, and the column. And we're going to get the adjacents around it. Okay, so if the grid, row, and column is empty, right? So it is an empty seat represented by an L, and there are no seats around it, right? So, and there are no seats around it, then we're going to say that our new row is going to add an occupied seat to it. So looking at our old grid, if that seat is empty and there are no empty seats around it, then we're going to occupy that seat. Otherwise, or else, if we have a grid, row, column is occupied, right? So if it's occupied and the adjacent dot count of occupied seats is greater than or equal to 4, you could also just say greater than 3, then we're going to empty that seat, right? Otherwise, we're just going to add the, typing is hard, man. The grid, row, column. Okay, and we're going to return the new grid. Oh, we also need to new grid dot append new row. Okay, so we're going through and we're making all the adjustments. Now we still need to go back and we need to do the part 1 adjustments here. Okay, so we're going to we need to essentially look at the grid, and we need to look at all of the different seats around it, and return the empty seats and the filled seats. I guess we could, in fact, just do the filled seats, because that's really all that matters. We don't actually care about whether or not there are empty seats around them, right? Adjacents. Pound not in adjacents. Adjacents.count the pound sign. So we don't actually care about the else. We can just use the symbols, the pound signs. So we'll have adjacents are going to be this for x in, and this is where we're going to say -1, 0, 1, and we're going to have, and I'm thinking of this like a grid, like a oh goodness, on a 2D basic math charts. I don't know what to call them again. For y in and we'll do the same thing, right? So we're doing all the values that are surrounding it. If x equals y equals 0, right? If it's the origin point that we're searching around it, then we will just continue through the loop. We don't want to count that seat as being part of the adjacents, right? Because it's not adjacent. Otherwise, if 0 is less than or equal to row, right? We don't want to look at anything that is part of the. We want to make sure that our row plus x is not less than 0, because we don't want to be looking at the other side of the plane essentially in our index, because that's not an adjacent seat. And we want to make sure that this is also less than the length of the grid, right? That we're not getting, so we don't want to go on the other side, and we don't want to go past the length of the grid. Otherwise we get an index error, right? And we want to do the same thing here for the y, except that y is going to be column, and this is going to be grid 0, right? Oh, there we go. We will append to the adjacents the grid row plus x and column plus y. So we're going to append that value. Now we don't technically care. We could include whether or not it is in fact a pound sign, but to keep it short, we'll just include this. And now we just have a list of all the strings that are adjacent, and we can return the adjacents, just like that. Okay? So if we did this correctly, and we kind of worked our way backwards, right? We understood, okay, here's what we need to have happen, right? We need to count the number of pound signs in our finalized grid after it is no longer changing, right? And we need to process that every single time we go through this iteration, process the part 1 seats. And then we, during these part 1 seats, we're going to have to get the part 1 adjacents, or the seats that are adjacent to it. I'm guessing that we'll probably reuse this in some way for the second half. Okay. Okay. So let's run that and see what we get. 37. Okay. What was the correct answer here? 37 occupied seats. So that's promising. That seems to indicate that we will in fact get the right answer once we have our input. So let's actually get our puzzle input, prepare for the brightness, because it has no dark mode for the inputs, which is fine. It's simple. Okay. and then let's rerun this, and let's find out what the response is. Ooh, that took a while to run. Not terribly fast. Not terribly fast. I'm sure there's a mathematical way to actually look at this and determine what that might do, but the while loop is definitely the simplest solution, I think. Okay, perfect. Okay, that is the correct answer. We will continue on to part 2, but we're actually going to split this into 2 videos. So for right now, we have finished the solution to part 1. We will continue on to part 2. Hope this was helpful. I know that we went through quite a bit of code here, so hope this was helpful and useful. And we'll continue on with part 2 in the next video. If you like this video, like, subscribe, right? If you feel like it, share. Otherwise, have a great day. Good luck on Advent of Code, and I'll see you in the next video shortly.